Now let's solve this nice geometry problem. So we have a square ABCD with the side length 16, right? So this is 16, this is 16, right? And then we have a right angle triangle CEF, and this angle is 90 degrees. Right? We know the area of CEF is 200, so the area of this triangle CEF is 200, right? And then we need to find out what's the length of BE, right? It's the side length of this triangle, right? So don't forget this is a 90-degree angle, so CBE is also a right angle triangle, right? So this is a 90 degrees. So this is 90 degrees. So how do we get the value of BE, right? If we can get the value of CE, then this side is 16, right? Because it's one of the squares. It's one of the sides of the square. So this side is 16, right? Right. So if we can figure out what's the length of CE, then we can figure out what's BE, right? So how do we actually get the length of CE, right? How do we get the length of CE? Let's look at another triangle that's CDF. CDF, this triangle, this triangle, right? CDF, and then we're going to compare CDF with the triangle CBE, this triangle, right? So what I claim is that these two triangles are identical to each other. They are the same triangle. Actually. Why is that, right? We know this angle is 90 degrees, this angle is 90 degrees, right? We have one angle that's the same. What about the side length? This side length is 16, right? This side length is 16. So this side length is the same. We just need one more condition, then we can figure out then we can say if it's identical or not, right? Which is this angle. So this angle is equal to this angle. So the angle DCF equals to the angle BCE. Right? Why is that? Why is that? Right? Because we know the angle DCB is a right angle. It's a 90-degree angle, right? So because the angle DCB equals 90 degrees, right? So this is one of the angles of one of the corners of the square. So this is 90 degrees, right? So DCB equals what? DCB equals to this angle, the angle DCF, plus the angle FCB, right? And we know that this angle is also right angle, right? It's 90 degrees. So FCE is also 90 degrees, right? And this angle is what? This angle is made up of this angle, which is ECB or BCE, plus the angle FCB, right? So 90 degrees, 90 degrees. FCB, that's the common angle, right? If we use equation 1 and equation 2, if we subtract each other, right, that's 0 equals to angle DCF subtract angle BCE, right? So angle DCF is what? Angle DCF is this angle. That's this angle. Subtract this angle BCE is going to equal to 0, right? If we use 1 subtract 2, that's going to give us this result, right? So that means the angle BCE equals to the angle DCF, right? So these two angles are also identical, right? So we have 3 conditions that are identical. So this side equals to this side, this angle equals to this angle, right? And then this angle is 90 degrees and this angle is 90 degrees, right? So these two right angle triangles are identical to each other, which means what? Which means this length CE is actually the same as this length, right? So this triangle has 2 equal sides. This is a right angle triangle that has 2 equal sides, right? So how do we evaluate the length of CE, right? So the length of we know the area of the triangle CEF is 200. So what's the area of triangle CEF, right? Which equals to CE. That's denote the length of CE as big L, right? Big L. So it's gonna be L times this. If we treat this as the base, then this is the height, right? And the height has the same length as the base, right? And then divided by 2, which is L squared divided by 2, right? And this actually equals to what? 200. So L squared equals to 400, and L equals to 20, right? So now we know CE is 20, and this side is 16, right? So what's gonna be BE, right? So BE, the length of BE is gonna equal to square root 20 squared subtract 16 squared, right? And that's gonna be square root of 400 subtract 256, right? That's square root of 144. That's equals to 12, right? So the length of BE is 12, right? That's the answer.